Okay, I'm just going to pick up where we left off in the last video. So basically what I did was I disassembled the head and I started grouping parts and components by system or subcomponent, and then we were stashing those in Ziploc bags to kind of keep things organized so that when you went to put that component back on, you had all the hardware sorted and situated, because they do use common fasteners throughout this this mill, and so if you wound up with a big canister full of mixed fasteners, it may be difficult to find out which one what goes where. This was super helpful during the reassembly process. It was easy to kind of grab a specific component and have all the fasteners there. Like I said, the common standards are used throughout the mill with adjustments in grip length, and so it would be difficult to sort through that if you had all the fasteners and components kind of just lumped into a bag. Okay, now that the head was taken apart, basically what I did was started stripping down all the castings. I used some rotary tools, steel brushes, wire brushes, 3M pads, and chemical strippers to kind of take all the existing finishes off. It appeared that my mill had been previously painted using some kind of primer or top coat that really wasn't suitable for exposure to your typical solvents and lubricants. It had started to peel, and there was a lot of areas where the second coat they put on had started to disbond. It's important that if you do go about trying to paint this component, that you use all the proper safety equipment. Keep in mind that a lot of this paint may be chromated or have lead or other substances in it that are toxic, so protect yourself. Also, it's important that you go all the way down to the substrate so that when you repaint, you get a good adhesion to the actual metal. You don't necessarily know how good the bond strength is on the existing paint, and so it's best to, like I said, go all the way down to the metal and then use a proper primer prior to application of the top coat so that you can guarantee that your finishes will stay for as long as possible. So I used a Sherwin-Williams industrial enamel to repaint this. You can see in this picture I used the chromated primer that comes with this system that I used. They have good industrial enamels that'll hold up to like industrial applications. Okay, after I stripped everything down and primed it, we started putting the top coat on. You can see here that I use orange. I kind of did that as a joke because we have Kuka robots at work and they use a similar color paint scheme, so I was trying to play off of that. It's noteworthy to add that all of your mechanical interfaces are tightly machined and should be masked prior to painting. After I painted all the cosmetic surfaces of the Bridgeport head, I went ahead and polished the upper and lower bell housings. Basically, I have another video that I provided to show the details of how to do that. You can strip all those aluminum surfaces and then polish them to a mirror shine. Painting all the head surfaces, I went ahead and pulled off the ram. It's noteworthy to add that at the onset, the ram was actually seized, and so it couldn't be translated forward and aft. And so what I wound up having to do is I put a piece of wood block at the back and used a crowbar to kind of free it. And then once I got it free, I was able to clean out and grease the ways so that the thing could articulate back and forth. I used a 5/8 inch eye bolt to screw into the top of the ram and a engine hoist to lift it. These components probably weigh somewhere around 400 to 500 pounds, so be careful. This picture kind of illustrates how much this machine had been used and how long it's been in service, but the entire I guess base casting was kind of full of steel and titanium chips. Here's a picture of the mill with the head and the ram removed. When I took off the ram adapter, I found this Allen wrench that had been dropped underneath those two lugs there. This picture shows the RAM adapter interface. You can see how packed with grease and metal filings this thing was. It was definitely ready to get cleaned out. After I took the RAM off of the mill, laid it down on the workbench in my shop and turned it upside down, and there was, I mean, just a whole bunch of filings and machine chips that had accumulated up in there, and it took me a long time to get up in all those little surfaces and get all that cleaned out. The next couple images show various RAM components that were stripped down using wire brush and some chemical stripper. I have another video that shows how to use chemical stripper to take paint off down to the substrate. Anyways, you can see the little pink on some of these castings, and what that is Bondo, or some kind of filler that was put in place at the original factory just to fair the casting surfaces in. After everything's stripped down, like I said, it's important to mask all the interfaces so you don't get paint in it. Removal can be a pain in the ass. The next series of photographs basically shows various RAM components after they were stripped down and primed. It's important to use at least 2 coats of primer, and you want to go pretty light on the first coat just to really establish that bond. And so if you put down a very thin coat and let that flash off, and then you could add to it, but it's important not to put too thick of a coat in one application. In the next couple pictures, I'm showing the painted RAM and RAM components. Basically what I did was I used a small foam roller and rolled all that on. The Sherwin-Williams industrial enamel does a pretty good job of flattening out after application. After 2 to 3 applications of the finished coat, I went ahead and masked this area off you see here with the letters and painted by hand the black inside of the letters with a small arts and crafts size paintbrush. Just for fun, I masked off the back of the RAM and added 2 racer stripes on that go down the length of the RAM. After applying the black enamel, I allowed it to cure for probably 48 hours before removing the masking tape, just to make sure it came off good. In this picture you can kind of see the RAM as it was. After I reassembled it, I sat it on my shop floor on top of some 2x4s just to make sure that the ways weren't damaged during storing. The next component that I took off was the Bridgeport table and the saddle. So I took the table off and just kind of stashed it somewhere in my shop, and then I started disassembling the saddle. In order to get the 2 components apart, you have to remove the table screw. You can see that this saddle was fairly caked up with old oil and chips and debris and so on. So it was pretty nasty. This is what it looks like after 30 years of accumulation. I also took all the lubrication lines out and cleaned those out with pipe cleaners. I used a lot of solvents on this. One of the things that really helped was the fact that I took a lot of pictures, and it helped me put all these little components back together. I really wasn't sure about the condition of these lubrication lines when I reassembled it, so I bought a roll of that piping and used the heat gun to kind of rough it all back in, just to make sure that I was replacing the existing lubrication lines with some hose that wasn't clogged or so on, because it was, like I said, difficult to test. So after I got everything cleaned up, I went ahead and primed and painted the saddle. The next thing I took off was the knee. This component is pretty awkward and difficult to handle. Again, I used a engine hoist to pull it up the ways. It came off of the base fairly easily. There's a method described inside of the Bridgeport refurb manual that I'll have in the description. It kind of tells you how to use clamps and a bar to lift that thing up. The next couple pictures were added just to show you the general condition of the mill and some of the subcomponents. I went ahead and stripped that casting down using the same method. I believe I actually created a video of stripping this component, so if you want to go, I'll put a link to that down below. Then I primed a couple coats of primer, and then I also put top coat, and of course added the racer stripes to the knee. The last remaining component was the base. I went ahead and stripped all the electrical components off at this point, and I left it on its original pallet, which worked out pretty good because it kind of functioned as kind of a paint drop to prevent me getting paint and everything else all over the floor. I have my Harbor Freight electric buffer that I bought. Basically, I took the buffer off and found a wire wheel that was the same screw pitch and diameter, and that was really helpful in stripping this casting down to the substrate. I think the wire wheel that I found at Northern Tools to fit on that buffer, it was somewhere around 7 or 8 inches, but it's pretty good at stripping down like large surfaces without a lot of effort. The next couple pictures just show after priming and after top coat application. At some point after I put the top coat, I used the engine picker to pull the base off of the pallet just to get it on the floor, and then I put it on some 2x4s for temporary storage, and then ultimately I used some iron pipes to roll it around in my shop. I have another video out there that shows how to do this. It's really easy to move the mill around. I believe this section weighs somewhere around 1,000 pounds, so be careful. Once it was kind of in the place that I wanted it to be, I finished the finish painting, and you may have noticed, but I also applied a coat of epoxy to the floor of my shop. I anticipated getting solvents and lubrication and so on from the mill on the shop floor, and I wanted to provide some kind of means of protection, and it was necessary to do this before I put the mill in its final place for obvious reasons. So I had to stop and strip the floor down and go ahead and apply that epoxy several days before I moved the mill into its final place. I also have a video that shows that the process of applying epoxy to the garage floor. Again, I used the Sherwin-Williams system to do that.